All right, boys and girls, welcome back to the drive-thru for another wonderful edition sponsored by the deli. Hungry? Stop by the deli. Get yourself some chocolate-covered raisins. All right, this is 8.5. These are three theorems that aren't exactly intuitive, and so sometimes these are the ones that students forget the most often. So it's good for you that this section precedes the test, because hopefully these theorems will be fresh on your mind when we take the test. All right, so here's the first one. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those two sides proportionally. Let's see what the heck this is all about. So here we got a triangle, and then here we've got a line. Let's make that parallel if we can. Okay. So in this case, these two lines are parallel. So if we've got sides A, B, C, D, and E, this doesn't involve E at all, other than the fact that E is parallel to the blue line. What we can say is that A is to B, the top left is to the top right, like the bottom left, C, is to the bottom right, D. Okay, we could also say this, though, like A is to C, top left is to bottom left, like B is to D. Okay, like top right is to bottom right. And maybe you're wondering, well, which one of them is right? Both of them. They're both right. That's what makes them proportions. If you think about two equal fractions, 2/6 is equal to 1/3. We could also say that 1/2 is equal to 3/6. So the fact that we have different options is because when you have equivalent fractions, that's just how it works out. It's just a phenomena of equal numbers, of ratios, okay? All right, second theorem. If three or more parallel lines are cut, oh, that one moved, you jerk. Are cut by two transversals, okay, then the parallel lines divide the transversals proportionally. So here we've got an A, a B, a C, a D, an E, and an F. There are so many things we can say here, I can't possibly list them all, but you can say A is to F, like B is to E, like C is to D. All of those are true. But you could also maybe choose to ignore this line, and you could say, for example, A plus B is to F plus E, like, let's say C is to D. That's also true. So I won't keep drawing all of them, but there are many, many proportions you can come up with from this theorem, okay? And finally, the third new theorem for today says, if a ray bisects an angle of the triangle, it divides the opposite sides of the angle into segments that are proportional to the adjacent sides of the angle. Remember, opposite and adjacent, these are going to start becoming really popular words in this class, okay? Opposite is what's directly across from you. I think you guys are comfortable with that word. But adjacent is someone that shares a property line with you. They are your next door neighbor. So here we've got angle 1 is congruent to angle 2. That has to be true. So that has to be bisected. All right, well, what we've got here is these are the sides that are opposite from our angle that has been bisected. These are the sides that are adjacent from the angle that has been bisected. So in this example, A is to X, like B is to Y. Bottom left is to left, like bottom right is to right. Or you could write that like A is to B, bottom left is to bottom right, like left is to right. Those are both true proportions. They're both equivalent fractions. All right, so let's just do one example and turn you guys loose. Example, find Km if Kp is 24. So that's our x, and from here to here is 24. So x matches up with 5, and 24 matches up with, well, that would match up with 5 plus 8 plus 2. Okay, so you got x. Notice that 24 represents the sum of 1, 2, 3 segments. So that's why we're matching it up with 1, 2, 3 segments. So x is to 5, like 24 is to 15. So x is 24 times 5 divided by 15. And I believe that should be 24 times the third. That should be 8. So Km equals 8. Boom!